Hello. You might have need to install third-party software on Kubernetes. You might have used different methods to install this. One approach we use is to apply manifest file to the Kubernetes cluster by downloading them from directly the vendor or by directly applying these or getting these files from the provider. The other approach is to use something like Helm. Helm gives us a package manager for Kubernetes. We can package the whole application with its dependencies and all the things that are required for deploying, let's say, services, then exposing them as ingress and having the deployment, stateful set, secrets, config maps, all those kind of Kubernetes objects can be packaged together as a chart, and we can use Helm Package Manager to deploy that. The other approach could be to use operator, where these things are managed by a Kubernetes operator and it knows how to apply these Kubernetes objects to the Kubernetes cluster. In this video, we are going to see how to use Helm charts to deploy a package or to deploy a third-party software onto our Kubernetes cluster. My name is Nilesh and let's get started. This video is about installing RabbitMQ. I've been using RabbitMQ for quite a long time for some of my personal projects, and I deploy them to Kubernetes cluster using Helm. As I said, Helm is the package manager for Kubernetes. So let's see how we can use Helm to deploy RabbitMQ onto our Kubernetes cluster. Let's head over to the command line and use the Helm CLI or command line interface to interact with the Kubernetes cluster and Helm. To get started, once we've installed Helm, so I use Chocolatey as a package manager for Windows. There is also a Brew package for Helm if you are on Mac. So we can use Chocolatey or Brew or whatever is the package manager to install Helm CLI onto our local environment or on our laptop. Then we can use the Helm command to interact with Helm. If I run the top level Helm command and I can run Helm-H, which is like a default command, we can see that it has got common actions, like we can search for charts, we can pull charts from a local repository or from a remote repository. We can install these to Kubernetes and we can list the releases. In terms of Helm, the package or the contents of the Helm package is called as a chart. It's like a template, similar to what we have in containers, where we have a container image and then there is a running instance of that container, which is the container itself. So same way, chart is like a template and release is like the installed version of that particular template. It also supports, or it also has various environment variables which we can override if there is any need for us to override these. And then there are various commands which allow us to use the Helm CLI to perform operations. Like we can create a new chart, we can get the history of the releases, we can install a chart onto the Kubernetes cluster, we can list all these releases, and so on and so forth. So let's start by first looking at what are the list of releases that I have, or what do I have currently installed onto my Kubernetes cluster using the Helm list command. I've used Helm to install things like Cert Manager, Loki, which is a log aggregation solution, Open Telemetry operator is installed, and we also have Prometheus stack installed using Helm. Now I want to install RabbitMQ. When it comes to RabbitMQ, it requires various things, like there is a stateful set which is required for managing the state of the messages which are sent to the RabbitMQ cluster. There is the RabbitMQ pod which is running, there is a service, we have the RabbitMQ UI. All these things, they need to be installed as part of RabbitMQ installation, and that we will do using Helm. So first, let's start by looking at what are the RabbitMQ releases, or what are the RabbitMQ charts that we have which we can use to install on our cluster. If I do Helm search repo and RabbitMQ as the keyword, we will see the list of repositories or Helm repos which are available publicly for us to deploy RabbitMQ on our cluster. We have one in the Azure Marketplace. That is the name of the repo, and the name of the chart is RabbitMQ. Same way, there is RabbitMQ cluster operator. If you want to use the operator based approach, Bitnami has a RabbitMQ chart, and same way RabbitMQ cluster operator. And then there is a Prometheus community repo which has the Prometheus RabbitMQ exporter for exporting the RabbitMQ matrix to Prometheus, or RabbitMQ matrix in Prometheus format. I'm going to use Bitnami RabbitMQ. To get started, the first thing we have to do is to add this particular repository to our local repositories. So I start by running this command, which is Helm repo add. Then we give Bitnami as the name for our local repository, and then we give the URL to the Bitnami chart. And here we see that the Bitnami repo already exists in my local because I've used it in the past. If you don't have it, it will create that link to the external repository. The next thing we do is to update the repository with the latest set of changes that might have happened in the remote. So when I run the Helm repo update, it will update all the repositories or charts that I have locally on my laptop. The next thing I'm going to do is to see what are the values which are supported. Once I have the chart, I can use different overrides as per my needs to override the default values. Most of these charts, they come with default values so that they can be installed very easily onto Kubernetes cluster, but sometimes we have to override them, and we can see the list of values which can be overridden. Here we can see things like the image, from where the image is for the OS shell repository is used, what is the tag for that image. We have the parameters, then we have a huge list like the Prometheus rules. For example, if you want to enable the rules, by default it is not enabled. We see enabled is equal to false. If you want to enable a rule, we can then go ahead and override this to true. And like this, for various objects that would be created, various Kubernetes objects that would be created as part of this chart, we have various attributes or properties which can be overridden. Say for example, service monitor, by default it is not enabled and the interval is 30 seconds. So if we want to override any of this, we can use two ways to override it. One is the command line itself, where we run the Helm install or Helm upgrade command. We can set the values, which is what I'm going to do here. The other approach is to create a file called as values.yaml, and we override the specific values there. So let me show by running the first approach, where on the command line itself we override the values. I'm running the Helm upgrade command here with install as a flag. This is like kubectl apply, which is going to incrementally apply the changes if they don't exist, or if they exist. If the release doesn't exist in our Kubernetes cluster, it will install it. So it's like a fail-safe approach, incremental or update kind of scenario. So I'm going to use the version 10.2.1 here. This version is the version of the chart, and I'm specifically using 10.2.1. There might be other versions available. The values that I want to override is, for the authentication purpose, there is the username field. When we want to connect to RabbitMQ, it requires a username and password, and for demo purpose, I'm overriding it to user and password. If we don't specify this, it would generate a dynamic value for the password, and the username would be user or admin, something default would be provided here. And we will have to then query the either a secret or a config map where these values would be stored. We also override the alarm cookie, which is used for internally managing the communication between the different nodes of this RabbitMQ cluster. And we are enabling the matrix, which are the Prometheus matrix in this case. And we specify RabbitMQ as the name of the release, and the chart that we are going to use is Bitnami RabbitMQ. With this, I'm going to execute this command, and it is going to create this release on our Kubernetes cluster. Since we don't have it, it says that release RabbitMQ does not exist, and it is installing it now. Once the objects which are required for RabbitMQ are installed, we will see what all things are created as part of this Helm installation. The reason we use Helm is sometimes there are interdependencies, and if we were to manually create all these things ourselves, it could be a quite tedious process. The order in which we have to create different Kubernetes objects, it requires a bit of knowledge how things work. When we are dealing with third-party software or dependent software like backing services, databases, messaging queues, it's better to use Helm chart, which gives us various defaults and a way to override things that are required for our purpose. So here we can see that the RabbitMQ has been installed on our cluster, and the Helm chart gives us instructions about how to get the username. As I was saying earlier, there is the username and password. We can use this command kubectl get. It's created as a secret, and by running this json part data.rabbitmq-password and then decoding it to base 64 from base 64, because by default secret stores data in base 64 format. We can get the password for that, but we already know what is the password because we provided that as part of our installation. And it also creates things like persistent volume claim. There is the RabbitMQ UI, which is available on 5672 port, and the AMQP protocol where we can send the messages, using which we can send the messages, is running on 5672. The UI is available on 15672, the management interface. And if we want to access the matrix, we can access the matrix on 9419 using the matrix endpoint. So these are the different ways in which we can interact with this particular RabbitMQ. So let's go ahead and copy this, and we can see how to go ahead and connect to the RabbitMQ. So I'm going to use that management interface, but before we go and use the management interface, I have to do the port forward from my local machine to the service which is exposing that RabbitMQ management interface. So let's open a separate tab here in our terminal, and let's run that port forward command. So here we do the port forward. Namespace is default. We can in fact exclude the namespace part, and we are connecting to the RabbitMQ service on port 15672. And we have a copy paste error here. Let me just remove the duplicated code or duplicated command. And when I do the port mapping for 15672, this will start port forwarding from my local 15672 port to the remote 15672 port. Now if I go and open this in my browser, if I say localhost 15672, I would be presented with the user interface for RabbitMQ, and it will ask me for username, where we specified user as the user itself and password as password. Please note that for the demo purpose, I am putting this in clear text format when I was running that command. In a production like scenario, you should find other ways and means where these secrets and credentials are using some secret management solution, and you're retrieving those secrets and passing them as environment variable or by some means. Do not expose them directly to your cluster or anywhere. So now I'm able to connect to the RabbitMQ user interface using the management UI, and I can then perform all the operations. Like I can create new queues, I can look at the admin options here. All the operations that I can do with a normal RabbitMQ queue, I can do using this interface. Now let's look at various objects that were created as part of running the Helm install. So if I do kubectl and we get all the objects in our cluster, we would be able to see what objects were created. So let's run the kubectl get all command, and without any namespace here, because we didn't specify the namespace, everything was running inside the default namespace itself. I had some objects running previously, so we will see the output from the previous installations. but we can make out what got installed as part of the RabbitMQ. There is a pod created with RabbitMQ 0. When we have RabbitMQ 0, this is a stateful set. So we know that this is managed by a stateful set. Then we have under the services, if we go down, we have the RabbitMQ service, which is exposing 56724369, 25672, 15672, 9419, and these different ports are exposed. There is also a headless service which is required for RabbitMQ. So this is created by Helm chart. So this is what I was saying earlier. The two services, one which is a normal service and one which is a headless service, is created, and the dependencies between them is all managed by the Helm chart for us. If we go down under the stateful set, we see there is a RabbitMQ stateful set also created, and all this was created about 5 minutes back. The other way of looking at this is using a visual tool like Octant or Lens. I've been using Lens quite a lot recently. So if I go into, let's say, config maps, for example, and I want to look at what were the config maps, or what are the different config maps available in my cluster. Here we see all the config maps, and we know that a secret was created because at the end of that Helm chart installation, we saw a couple of commands, one related to the Erlang cookie and the other one was related to the RabbitMQ username and password for admin. So these two are created as part of the secrets. If we go under the services, we would be able to see those RabbitMQ and the RabbitMQ headless services listed here. And if I click on the RabbitMQ, we will see the list of all those ports where it is exposing different ports for metrics, stats, and the regular AMQP port. So this way, we saw that it is very easy to use Helm CLI to deploy a third-party software. We can use Helm even for our own projects, but in my experience, this is mostly used for external software that we use or that we want to deploy on our cluster. Now, the last thing I want to show is how do we list the releases? So how do we delete the releases? Let's first do Helm list, and that will give us the list of releases that we have installed using Helm CLI. And now we see that RabbitMQ is part of the listed release here. If I want to remove this RabbitMQ, it can also be done. So as I was saying, that Helm is a package manager. It gives us a complete solution to install, upgrade, and delete third-party software. I can do Helm release and remove, or let's do Helm remove, and the release name is RabbitMQ. Sorry, it's uninstall. So if I do Helm uninstall and give the name of the release that I want to uninstall, we can see here in the output that the release RabbitMQ has been uninstalled. And quickly we can see the same thing by going into Lens UI, and under the Helm and releases section, it should show that we no longer have the release RabbitMQ. So we only have cert manager Loki, the OpenTelemetry operator, and kubeprometheus text with which we started initially. That way we have seen how to install, how to upgrade itself. Upgrade is simple because if I run the same command again, it would do the upgrade. Upgrade is useful when I want to change something on an existing release. So let's say I want to change the username or password, or I want to change the version. In that case, I would use the upgrade command. Otherwise, I can use Helm install, and instead of upgrade, it would be a normal installation. So in three simple steps, we can use Helm charts to deploy things like RabbitMQ or other software. First thing we have to do is to add the reference to the repository using Helm repo add and giving a URL to the place where the repository exists. Next thing is we update it locally into our local repository by running the Helm repo update command. And finally, we use the Helm install or Helm upgrade command to install it into our cluster. I hope you found this useful. If you want to understand more things about how we interact with Helm, I did a video recently on how to use the Lens UI to install Helm charts. So if you prefer a visual way of installing Helm charts, you can refer to that video. I hope you found this useful. Thanks for watching it once again. Do subscribe to my channel and hit the like button. And until next time, code with passion and strive for excellence.